here we're going to look at example 70, topic 5, topic 70, example 5, write an equation of a transform function. So they're telling us the function g is a translation of the parent function f, 1 unit left and 3 units up. What is the equation of g? Write the quadratic function in vertex form and in the form f of x is equal to ax squared plus bx plus c. All right, so this one's pretty straightforward. What we're going to do is we have our vertex form of y equals a times x minus h squared plus k, and they're telling us what the transformations are, or the translations are. So we're going to take y, our a value doesn't say anything about a stretch or compression, so we're going to leave that as a. They tell us that it goes 1 unit left, so that 1 unit left is my h value. So that's going to become x plus 1. Remember, it's backwards. So we're going to say x plus 1. And then they tell me that it goes 3 units up. That's going to be my k value. So I would add 3. Now in this case, I mean, really what you should do is you should plug in an x and a y value, which is kind of, we have other numbers here that we can use. You can use whatever point that you want to. We have this -1, 3. We have this point 0, 4 here. So maybe I would use 0, 4 as my x and my y, and just kind of make sure that the numbers work out, and then I can figure out what a is. In this case, they didn't mention anything about a stretch or compression or a reflection, so a really should just wind up being 1, but we'll work it out anyway just to show that. So the y value is going to be, the x value we'll use as 0, the y value we'll use as 4, and this is really just the same thing that we've been doing on the last 2 examples. So just plug your numbers in just for I don't want to say the sake of plugging them in, but it kind of feels that way in this case. We kind of know what's going to happen. So 4 will be equal to 1 squared plus 3. So 1a plus 3. Subtract 3. 1 equals a, so we're good there. So my vertex form, write the quadratic equation in vertex form. So y is equal to a, x minus h squared plus k, or a is 1 in this case. So we could say y equals 1 times x plus 1 squared plus 3. We knew what a was going to be, but they asked for it, so we'll just write that out. You don't need to show that a value anymore, so we can kind of remove that. It's just a 1, it's not going to change anything. They also want us to write this in the form f of x equals ax squared plus bx plus c. So let's take our equation, this x plus 1 squared plus 3, and we can multiply everything out. I don't want to oversimplify this problem, but really what's happening here is the same thing that we've done in the last 2 examples. So hopefully you're getting a pretty good understanding of this at this point. So we just combine these like terms. So we should get y equals x squared plus 2x plus 4. And these would be my 2 solutions, right? We have vertex form, and we have y equals ax squared plus bx plus c. If there is a stretch or a compression, sometimes you'll need to see that, and you'll actually have to solve, the a value might be something other than 1. But in this case, all we did was the parent function was just shifted up and left. There was no stretch, there was no compression. So we didn't really have to worry about any type of a value other than 1. Maybe there would have been a reflection, but in that case you would get a -1. Everything worked out quite nicely for us. And that's all for this topic.